now we are good to go. So, welcome to pre-algebra. Exciting day. Lesson 1. Here we go. Lesson 1-1, rational numbers as decimals. And even with the title of the lesson, we got to pause for a minute and talk about some stuff, because what the heck is a rational number? I can see by your blank looks that you're not sure. Okay, so do you see, take the first 5 letters of rational, and what word do you see in that? Bryson?
It's a fraction.
Okay, the first 5 letters, R-A-T-I-O. So ration is a word that we use, but the first 5 letters is ratio. Ratio. What is a ratio? Emery?
Isn't it like where you kind of compare two numbers?
Yes, 2 numbers compared to one another make a ratio, and usually when we set up a ratio, we set it up to look like a fraction. That's a ratio, 3/4. Okay, 3 out of 4 dentists recommend Trident gum or something like that, you know, the commercial says. So that's a ratio. So rational numbers are numbers that can be written as ratios, as fractions. Okay? So how many numbers are there that can be written as fractions? Oh, a whole bunch. Like billions and millions and infinite. Okay? So lots and lots of numbers can be written as fractions. Even if you take just a whole number, like the number 12. Can I write the number 12 as a fraction?
Yeah.
How would I do that?
12 over 1.
12 over 1. You can take any number and make it a fraction just by making it 12 over 1. You could also do, you know, like 24 over 2 or 36 over 3. That's the same value as 12, but we could write numbers as fractions in lots and lots of ways. So we're going to take rational numbers, which is a number that can be written as a fraction, and we're going to look at it as a decimal. So we're going to do some that are fractions and turn them into decimals. We're going to turn some that are decimals and turn them into fractions. Have you done that kind of stuff before?
Yeah.
Sure, yeah, you've done that in previous math classes. Okay, so this is where it gets tricky. I told you before we started the video that there's some tricky parts of this lesson. This is where it gets tricky. Repeating decimals. What's a repeating decimal? Mason.
When the number at the end goes infinite.
Okay, so it's like so 0.427, and if you put that little repeating bar over it, what's repeating?
7.
7 goes on into infinity, right? Just the 7 goes on. Okay, and if I extend that bar so that it's over the 2, now what happens?
27.
It's
2
the,
and 7.
right, it's 2, 7, 2, 7, 2, 7. So that repeating bar tells you what's repeating on into infinity. Yes?
How come white number 6 has like periods after it? Does that mean?
Okay, so there are different, so we could write it this way, where we have, you know, this is a repeating decimal as well, 1, 2, 2, that's 2, 2, dot, 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 dot. They put that, so that dot, 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 dot means and so on, and so on, and so on. So what's repeating in that decimal? The 2. The 2 repeats. And usually with that, they're not gonna, what they won't do, okay, we can do this, 0.1, and the line over that tells you what's repeating, right? Okay, typically, if you wouldn't see it like this, 0.1 dot, 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 dot. You're not just gonna have 1 digit there and then the dots. Typically, they're gonna put 3 digits and then put the dots. So 1, I said it and then didn't do it. 1, 1, 1, dot, 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 dot. And those 3 ones and then the dots tell you you've established a pattern, okay? So this is usually the way I'm gonna write on the board because it's a little simpler. But in your book, they like to do this just to throw a different way at you of doing things, okay? That's kind of typical. So we will see it written both ways in the lesson today. So we're gonna take, if it was just this lot right here, rational numbers as fractions, and we were just doing stuff like simple fractions and simple decimals, we'd be done with the lesson almost by now, because you guys know how to do this already. What makes this one tricky is that we're gonna get into these repeating decimals here. And then we have to learn some steps. We have to learn some steps to do this, to make it right, okay? All right, so it's totally doable. Just gonna be a little tricky. Here we go. First warm-up question of the year. Jalen has a wrench labeled 0.1875 inch. Timeout, stop right there. Charlie, you're a mechanic. Do you have any wrenches that are labeled 0.1875 inch? No, they don't label wrenches that way. This is a totally made up question. This is weird. But for the sake of the question, he has a wrench labeled 0.1875 inches and bolts that are labeled in fractions of an inch. So the bolts are labeled the way we would typically label a bolt, which is in fractions, and the wrench would just be labeled to match. They would not label it as a weird decimal. So we have to figure out which size bolt will best fit the wrench. Are there any of those bolts that you can easily switch from a fraction to a decimal?
3/16 maybe?
Well, all of them, we can do it. We can do the math. But is there any of them that, like, as you look at the four bolts, or any of them that you're like, hey, I know what that one is? Yeah, what's 1/4? 0.25. You know that, right? Okay. So 0.25. So is that bolt too big or is that bolt too little?
Too little.
Too little. No.
Maybe.
Compared to that number?
Oh, it's too big.
It's too
The
big.
bolt is bigger than that, so do we want to choose the bigger bolt or do we want to choose the smaller bolt to test?
Smaller bolt.
We want to choose the smaller bolt to test. That way we do it. So we're going to try 3/16. How do we take 3/16 and turn that into a decimal?
You got
Wait,
So
it'll
you
be
have
whatever
10
equals
divided by
what,
16.
16 divided by 3, I think.
Say that backwards.
3 divided by 16.
There we go. What does a line in a fraction mean?
8, it's 8.
Divide. The line in the fraction just means divide. So with your calculator, if you have one, or if, I've got one, I've got this guy here, so we can just do 3 divided by 16 equals
0.71.
0.1875.
Whoa.
Okay? So we found it. We found the bolt that goes with the wrench. So it's super simple to change a fraction into a decimal. Just divide it, right? It's a little trickier to change a decimal into a fraction because you have to do some simplifying along the way usually. And then when you get to the repeating decimals, that's where it gets really tricky. Okay?
Alright, now try find the socket side on that bolt.
Try to find try to change that to metric now because you don't have any standard wrenches, right? Okay. Here we go. Just something to think about. Why is it useful to write a rational number as a fraction or as a decimal? Why sometimes do we do this and other times we do this?
You can't always use a fraction in an equation.
Okay. Like, can you think of an example where fractions would be more difficult?
Like if you got regular numbers and fractions in the same.
Okay, so if you're doing like fractions plus decimals, it's easier to have both of them together.
Yeah, both decimals
Yeah.
instead of
Okay.
fractions.
All right. So, Emery?
Sometimes it's kind of confusing with, like, if a fraction is like 58 over like 36, it would be harder
Okay.
to do than that as a decimal
Yeah.
line number.
Okay, so weird fractions get hard pretty quick. Basic fractions like 1/4, 1/2, 2/3, we can kind of think in those terms, and I can understand those really easily. But if you get into some weird fractions, 27/37 of something, that's all of a sudden that's weird, and so it's harder to think in those terms. So decimals can simplify things for us a little bit.
Taught me.
Sounds like I got bleeped on the video.
Nice
All
job,
right.
team.
So
Hey, what did you say?
sometimes though, it just depends on what we're doing. If I'm out for supper with a couple of friends and we order a pizza and there's 4 of us there, we each get 1/4 of the pizza, right? And 1/4 is easy to think of when we're thinking about how to divide up that pizza, rather than I'm not gonna tell my 3 friends, hey, we each get 0.25 of the pizza.
I have to
That-
at least half.
Okay, so that's one thing, but when it comes time to pay for that pizza and we're gonna divide up the bill, we might say, hey, I'm gonna pay 1/4 of the bill, but when we divide up the money, we're gonna talk in decimal terms, right? Because money divides up into decimals way easier than it does into fractions.
Yeah,
So there's just different ways there are different times in our practical sense when it's good to use a fraction and other times when it's good to use decimal. So we need to be able to make those transitions and go back and forth. That's why we do this stuff, okay? We good? All right. Now, let's do this. Okay, so we're gonna do this problem. You sure this is in your books? Should be like page 6 maybe?
oh, we're not doing page 10.
It's page 10.
Page 10?
Thanks, guys.
Oh, my bad. Okay, that page 5 was like, that was like a readiness assessment thing, my bad. Okay, so I had told you page 5 earlier, but I was off, I was out of whack. All right, so yeah, that warm-up thing was in your book. Everything that I do up here on the screen should be in your book. Nearly everything. I'm gonna show you video here in a minute, but. Okay, so the Sluggers baseball team ended the season with the highest win percentage in their division was the Sluggers' winning percentage written as a fraction. So we are going to take, first I wanna, your book does this a little weird. I don't know why they set the problem up this way and then change it all of a sudden, but we're gonna take it just as it's written. Okay, so for now, just look up here and we're gonna take, what is the Sluggers' winning percent? What number is it?
The 556.
0.556, and I know your book kind of goes a different direction with this, and we'll address that in a minute, but we're gonna do this one as it is for now. So, now, how do we, you guys all said it, or those that answered said it, how do we read that number? What is that number?
556.
0.556, that's usually what we say, that's usually how we read decimals. I'm okay with that, it's not a big deal. But that doesn't help us write it as a fraction. If we say what the number is, it helps us write it as a fraction. So what is this number?
556
Thousands.
thousands.
556 thousandths. Look how easy that is to write a decimal as a fraction.
Yeah.
All you gotta do is say the number, and it tells you what the fraction is, okay? And so, I mean, so this part is simple. If this all the lesson was today, like I said, we'd be done, we'd be ready to make an assignment, you guys could go. But this isn't what the assignment is. By the way, what do you always have to do when you have a fraction? Simplify it. So we would simplify this, divide both those numbers by a common factor. What's a common factor of 556 and 1,000?
Is it like half of it?
Well, we can divide each of them by 2. So 556 divided by 2 would take half of each number.
278.
So 278 over 500. And then we can simplify that, divide it by 2 again.
I remember.
Whoops. 278 divided by 2. Why is it doing that?
You were saying?
278 divided by 2, 139. 139 over, then I forgot to divide the other. 250. I don't think that simplifies. That's far enough anyway for what we're doing today. Because this really isn't what we're doing. We're not doing numbers like this. But this is where I would have started. If I'd written the textbook, we would have started here and reviewed a bunch of this stuff. And we would have parked it here for a day and just kind of done some practice on these and then moved on. But we're going to move on now because that's what this book does to us. The point they make in your book is that often statistics are rounded. Right? Like when they put all the data into the calculator and they did the calculation, this isn't really the number that was spit out. They rounded that number. And how did they round it? Well, it was supposed to be 0.5 repeating, okay? 0.5 repeating is what the statistic should have been, but because calculators round things and we don't typically use repeating signs in daily use, we round stuff, okay?
So that's 560.
So, 0.555 and the 5 repeats. So,
Okay.
so what they do next for, well, the next slide, you have this in your book. So they have you think about that number for a minute, like 0.5 repeating. Where is that at on the number line, and kind of what does it mean to have a repeating decimal? Okay, and so 0.5 repeating is in between 1/2 and 0.6, or so 5/10 and 6/10, and it would fit in between those two on the number line. So then, the next thing they have to do, the next panel over in your book, this is where the trickiness starts. Okay, this is where we're going to get into some interesting math. And I'm going to take their example. They just give this example and lay it all out for you. Now I'm going to work through it on the other side of the board and talk about each step as we go. Okay? And so we have this repeating decimal, 0.5 repeating. Repeating decimals are hard to work with, because if I want to add or subtract something and it's a repeating decimal, I've got to have a lot of place values out there, right? Because it goes on to infinity. It goes on forever and ever. And so if I want to treat it as a repeating decimal and actually have it as an accurate answer, I've got to account for all of those things that go out there, even though I'm not looking at them, right? So, so we got to get rid of the repeating part is what we got to do. So this is algebra. So we always use variables. So we're going to say x equals my repeating decimal. X equals 0.5 repeating. That's where they start, okay? Now, I want to get that number in front of the decimal, okay? Because behind the decimal, it repeats. We don't have repeating numbers in front of the decimal, do we? Okay, we don't have a sign that goes the other direction repeating. We only go that way repeating. And so I want to get that number in front of the decimal so I can chop some stuff off. So what do I do to move this number so that it's in front of that decimal? I need to move the decimal one time, and I can do that by multiplying by 10. Okay, when I take a decimal and multiply by 10, what happens?
It goes back.
It moves it backwards one. Okay, so now I've got 10x equals 5.5 repeating. Okay, remember this one repeats, this keeps going. So the repeating part's still there. I just move the decimal over once. Okay, so I've still got the 0.5 repeating.
Oh.
Okay, you with me?
Yeah.
And this is where we're at here. We're at this line right now. Now, that repeating part is what's giving me the trouble. That's what makes life hard. So I want to get rid of it. How do you get rid of things in math?
Subtract.
Subtract it. So I'm going to subtract 0.5 repeating. Okay, so when I take off, think about those 5s going off into infinity. I'm taking all of them away. I subtract them. Okay, but if I subtract from this side, what do I have to do on this side?
Subtract.
Got to subtract from both sides. But this side doesn't have numbers. This side's got variables. But what does my variable equal?
0.5.
It equals the 5 repeating. So if I take away 0.5 repeating over here, on this side I can say take away x, and that's the same thing. X is 0.5 repeating. Does that make sense? Okay, so what is 10? If I have 10 x's and I take one away,
You got 9x.
got 9 x's. So 9 equals 5, because I took away all the decimals, and all I have left is that 5. Whoops. So now, whoops, I don't have 9 equals. Sorry, I forgot to put an x. 9x equals 5. My bad. That didn't look right there for a second, because I know that 9 does not equal 5. But 9x equals 5. Now, what's my last step to solve this sucker?
You gotta do the thing where you divide it by 9.
Divide by 9, so x equals 5/9. That's the fraction equivalent of 0.5 repeating. And how can I prove that I got the right answer? With my calculator.
Yeah.
How do I do it? What does this line mean?
To divide, so you do the opposite.
So
right?
5 divided by 9.
Never mind.
5 divided by 9 equals, look at that, 0.555555. Now, why does my calculator put a 6 at the end?
So it stops it.
Well, because it rounds.
Yeah,
Calculators don't know how to keep going on forever, so they round that last digit. So this is 0.5 repeating. Okay, we good?
Nice job.
Now, we've been through one example, so you guys are like ready to take the test, right?
No.
Oh my gosh.
Yeah.
No.
Really?
Okay, I'm not even ready to give the test yet. So, the Sluggers won 5/9 of their games. If they had 9 games, they won 5 of them. So let's go through another example. We're gonna do the same steps. This one I kinda like because they give us blanks to fill in. This is down at the bottom of your page. So our repeating decimal is 0.4, 0.4 repeating. So we start off by saying let x equal 0.4 repeating. Okay, so what's our first step? We wanna get that decimal moved where?
Back, so you,
Times by 10. We multiply it by 10 so that it can
Yes, we want to multiply everything by 10.
space.
So 10 times x and 10 times 0.4 repeating. So that gives us 10x equals 4.4 repeating. Okay? What was our next step?
Multiply them. Divide them.
the minus, no.
Minus, okay.
Minus.
And so this is, when they give us these boxes to fill in, sometimes I don't like the box they leave empty, but this is what they do. So this is just the same thing as we had up here. So 10x minus x goes here, and then 4.4 repeating minus, that's a bad mark there. Minus 0.4 repeating. Same step here, 10x minus 1x is 9x, and 4.4 repeating minus the 0.4 repeating is just 4. And then, last step, divide by 9, so x equals
4/9.
4/9. Okay, so, pause there for a second. Do you notice a connection between the one that we did on the last screen and this one?
It's the exact same.
It's the exact
Same
problem,
steps.
except it's
It's just
Okay.
4 instead of 5.
It's 4 instead of 5, and the steps are all the same, and the fraction ends up very, very similar.
Yeah.
I wonder
Is it 9 at
if
a time?
I'm gonna take a detour here. I wonder if we can make a prediction. Here was what we've seen. We've seen that 0.5 repeating equals 5/9. We've seen that 0.4 repeating equals 4/9. What is your prediction for 0.2 repeating?
Oh, it's gonna be 2/9.
Okay, let's check it and see. Okay, so we say x equals 0.2 repeating. What's my first step?
You times it by 10.
Multiply by 10.
Yeah.
So 10x, 10x equals 2.2 repeating. Then what?
You subtract 0.2 repeating,
Subtract x from that side, subtract 0.2 repeating from this side.
and then you have 9x
9x equals
and 2,
2.
Seven.
and then you divide by 9, and you got 2 9s.
Oh my gosh.
That's crazy.
We proved it. Okay, so what would your prediction be for 0.7 repeating?
I think it's gonna be 7.9.
That's going to be 7/9. What is your prediction for 0.3 repeating?
3/9.
Ooh, what do we have to do there?
You gotta simplify.
Got to simplify that one. So, but the pattern holds. We would do it. It would actually solve out all the exact same way. You'd end up with 3/9, but then you'd have to simplify, right?
So if we ever
So-
just have one repeating number, it's
So,
always gonna be done.
so shortcut. If one number repeats, and that's all you have, one number that repeats, it's that number over
9.
9.
But what about double digits?
We're gonna get there. That's what this next. And you want to you want to also blow your mind a little bit.
Well,
What about this guy?
1.
You're not wrong. That's it. It's a mathematical proof. 0.9 repeating is the same thing as 1.
Yeah,
Because when we solve it out, it would end up being, this is 9/9, and 9/9 is 1.
So why would people put that if they could just put 1? Or could they could just
Because
add
most
1?
people don't know it. You guys know something that most of the world doesn't know. Most of the world, if you said this, if you did like an inequality, 0.9, and you left the blank here like they do, and they put a 1, most people would put that 1 is greater.
but like,
0.9 repeating is less, but we can prove mathematically that it's actually equal.
aren't we gonna become most of the world? Cause,
But now you are enlightened. You now know the truth. This is the way.
what if I lose my enlightenment?
Okay. All right. So that's just one of those little mathematical oddity trick kind of things that you can do to, like, someday when you're old enough to go to a bar, you can win a bar bet
Well,
if you can remember the math. Okay. So, not that, and I don't, by the way, I'm old enough, but I don't go. So the question was then, what about double digits and what about other numbers that repeat? Well, that's kind of where we're at going here.
what page?
Let's see. Did we do this lesson in?
Oh,
This one seems
is it,
too
it's
long.
not page 11.
It rings at in 8 minutes.
Oh, it is page 11. I have a block about my stick.
Yeah, I did do this one. This is where I got to with the other class. So we did this one. So, with second hour. So we're gonna do this slide and this is where we'll stop for the day. Okay, so, guys, same steps. It's a different fraction or a different decimal. It's gonna be a different fraction, but it's still the same steps. So we would say x equals what?
Yeah.
0.26 repeating, okay? And so I kind of don't like the way the book does this because anyway, we'll fix it later. We'll do it this way, and then later we're gonna do it, tomorrow we'll do some play around with some other methods as well to solve it. So we're gonna do the same thing. What do we want to be behind the decimal? We want the repeating part to be behind the decimal,
Why does it have to be behind the
because that's what we want to subtract. We want to get rid of that. We don't want the decimal there. Although the way the book does it, I'm doing the exact same steps the book is doing. So multiply by 10, 10x equals what?
Yeah.
2.6 repeating. Okay, now what do I want to take away?
You want to take away 0.6.
Right,
So that
But-
would be.
but I have to take away an x. So I'm going to take away the 2.26 repeating. So I'm going to do minus x and minus 0.26 repeating. Okay, so this 6 actually extends there. That we can do that. So those 6's all cancel out, right? And then 6 minus 2 is 4.
So you
I've got a
have-
decimal 2 right there. And it equals 9x equals 2.4. Okay, now my last step is always divide by 9. Whoops, don't divide by x, that's weird. Divide by 9 and x equals, what's the problem here?
It can't be that. It can't be decimal.
We
over-
can't have a decimal and a fraction, that's it.
Yeah.
Decimals fractions always have to be simplified, but when we have a decimal inside of a fraction, it's called a complex fraction. If it's complex, it's not simple, right? So we've got to simplify. We just got to move the decimal over 1. So if we move the decimal over, that would be the same thing as 24 over 90. Okay, now then, the book leaves it there because it's just asking what did she put in her calculator. She may have done 24 divided by 90, and that would give you this number. She may have also done 4 divided by 15. If we simplify that, that would be 4/15. Okay, so there are different. She might have also done 2.4 divided by 9. I mean, calculators will do that, right? So that's kind of where the book. That's how the book handles that one. I'm not sure I like their methods. We'll maybe look at a different way of doing it. very similar, but just, it doesn't have this at the end where it has to be simplified. Okay, that's where we're gonna call it for today, because we only got a couple minutes of class left.
Cool. Thank you.
Tomorrow we'll finish the lesson and have some homework time.